three. Hello, hello. Yeah, welcome all. So let us start. In the last class, we have discussed the applications of IoT in home. So today in this class, we shall discuss the applications of IoT in cities, city domain. Right. So here we have 6 applications. Uh, uh, yeah, it is highlighting. So here we have 6 applications: smart parking, smart lighting for roads, smart roads, structural health monitoring, smart surveillance, and emergency response. So let us see, let us get into detail one by one, right? So now, first one is smart parking, right? The first application in city, IoT application in city is smart parking, right? So problems. First discuss the problems. Finding a parking slot or spot in the crowded cities is frustrating and time consuming. Right. Everyone has experienced this. Right. In cities, suddenly we enter a mall, we enter a building and find that, right. And we find that there is no parking slot. Then again, all the way we have to come out of the building. Right. It is quite frustrating. Right. So, what is the solution? Smart parking is the solution. What does it do? It helps the drivers find the empty slots using real-time data before they enter the building. Let us see how it works. Sensors detect if the parking slot is empty or occupies. See, like these sensors are there, they are placed like ultrasonic sensors, right? They will check, right, whether, see, now this empty is full, it will send the data that it is full. If this is like, it is like empty, any kind of indication or symbol you can use, right? Point is the sensors check out whether the slot is empty or occupied, right? That data is sent to the local controller where it is processed, then it is uploaded to the internet. See, it sends to the local controller, it is processed, and the processed data is sent to the internet where the users or the drivers can access the data. What data? Empty or occupied. Drivers access this information via smartphones, tablets, or car navigation systems. Benefits: saves time and fuel. Yes, of course, we enter the building, right? No parking slot. Till then, we have drive the car. Fuel was consumed, time was consumed. Again, we have to come back. That much fuel will be consumed, right? So now, by using this smart parking system, we save the time and fuel, reduce the traffic congestion, right? Like many people also come behind us finding this parking slot, empty slot, right? Some 5, 6, 7, 8 vehicles enter simultaneously, right? Then there will be a traffic jam. If we have prior information, we won't enter that building. Hence, there is no chance of traffic jam in that building. Improves efficiency and user convenience. Now, the second application is smart lighting for roads. Right? Traditional, right? See, this is like we have smart light in home, right? It is application here. The lights are on the road. That is street lights, right? Traditional. Now what happens? Traditional. Let us see the problems first. Traditional lighting wastes energy and lacks flexibility. Right? Street lights are on night 12 o'clock when no people are there. When no people are there, light is on. It is the wastage of electricity, lacks flexibility. Right? Sometimes in the winter season, it is dark early as 6 o'clock. Right? And the daylight will come in the winter season at morning 7 o'clock. In summer, at 7 o'clock will get dark, and in the morning 5:30 itself the daylight will start, right? So these are the flexibilities, right? So this confuses when to switch on the light, when to switch off the light. A person has to go manually, right? Light stay on full intensity even when it is not needed, right? What is the solution? The solution is smart lighting. What does it do? It adjusts the brightness and timing based on real time conditions. They adjust the brightness as well as the timing on the real time conditions. Like I said now, in the timing based, right? In summer the light has to remain on for shorter duration of the time. Nights are short, the light has to remain on for shorter duration of time. In winter season, nights are longer, the light has to stay on for longer duration, right? Lights can be controlled remotely, right? The lights can also be controlled remotely from far away places, from headquarters, from office, from for different situations, right? Now, how it works? Sensors detects ambient light, that is the natural light, that is the sunlight, traffic and weathers, right? As I said, weather is also a factor. Like I said, summer season and a winter season, and sometimes what happens, a cloudy day will be there. In the cloudy day there is a dark, so in that scenarios also the light should remain on, right? Data traffic, now the data goes to the local controller. Now what is the data? The data goes to the local controller, then to the internet. See, the data goes to the local internet, then to the internet. Lighting is scheduled and intensity are managed via smartphones or controls, right? Like this, with the smartphones and the controllers I can control the light intensity and the light durations also. Benefits, what are the benefits? Saves energy and costs. Of course, when the light is not on, when it is not needed, of course it saves the energy and consequently the electricity bill also. Improves road safety, right? Of course, when the lights are on whenever we need it, it is definitely have road safety, there won't be any accidents. Excuse me. Enables custom lighting, like said, right? Whenever there is a fog, we need light. At that time the lights are on, we can switch on the light. During festival, we can miss it automatically happens from far away places, either remotely or completely atomized, right? During emergencies, supports smart city infrastructure, right? Now let us get into the third application of the cities, that is smart roads, right? Let us understand first problems, then solutions, then it is clear that why they are called as smart roads. Problem, what is the problem, right? Now, drivers often face uncertain road conditions, traffic jams and accidents without timely updates, right? Uncertain road conditions, there will be a traffic jam, right? There will be accidents, sometimes we face, right? Whenever there is a traffic jam, then we come out of the vehicle and check out what happened. They say some 200 meters ahead there was an accident. Because of that accident everything is jammed, right? And this lack of real-time information leads to delays and unsafe driving, right? Now, what is the solution? Smart roads. Smart roads provide live updates, right, on driving conditions, travel times and alerts. They all give live updates. The information helps the driver makes safer and faster decisions, right? Now, how it works, let us see. The sensors are embedded in the road. They collect the data about traffic, about weather, about the accident, and when they collect the data they will send it to the internet, to the cloud based applications. See here, right? The data, the sensors about the road, they will send it to the cloud. Now drivers receive these updates through smart apps or the navigation systems that are exist in their car or on any social media. Because nowadays what happens, most of us will be on the social media, right? Browsing, right? We are discussing some topics with the friends in the media. So if we get such information, right, in social media search also, it serves better. Now benefits: improves road safety with timely alerts, right? Of course, right? Reduces traffic congestions and travel delays, right? Now we see in the maps, right? In Google Maps, it will show 2-3 alternative routes. It will say that if you go by this route, the road is good, but there is a traffic, it will take 90 minutes. If you take this route, the road is moderate, right, but you will reach 40 minutes, there is no traffic, right? Such all those things, we will get the information which reduces the travel delays, right? Enhance driver convenience with accurate travel time estimates. Of course, that's right, it gives the travel time estimates also, right? As I said just now, right? To it is this place is 100 kilometers away and it will take 3.5 hours to reach. Such estimations also will be given, right? Supports smart city infrastructure, right? Okay, now let us move to the next application, that is health structural health monitoring. See, many people what they saw, the moment they see health, they think that is a human health. No, you also have to observe this word structural. What is this structure? The structural means these bridges and buildings. See here in the image, bridges and buildings. Structure means structure of the bridges and buildings. Structure, and these structures health, right? What are the health? Like they can develop cracks, damage, or mechanical failures over time, right? So these are the health parameters of the buildings. So without detecting these as early as possible, these issues can lead to costly repair or hazards, right? So sometimes what happens, when we won't take the repair work as early as possible, that repair will grow, that repair will become big, that lead to a lot of repair cost, right? So hence repairing as early as possible is better, right? Solution: structural health monitoring uses sensors to track the vibrations and the stress levels. Okay, so we will check the vibrations. So you see here, you can see some sensors on the bridge. They are checking the when the vehicle moves, when the big lorries or buses move, it will check the vibration level of the bridges. If that vibration level is beyond some cutoff, we can tell that that bridge has some problem, right? So this helps in detect damage early, right? Yes, detecting the damage is as early as possible is better, because one is repair cost comes down, as well it has also saves the life. Assess structural integrity and estimate remaining lifespan. Let us see how it works. A network of sensors is installed on the right. Here you can see a network of sensors are installed on the structures. Here on the bridge it is installed. What are these sensors doing? They are measuring the vibrations, they are measuring the strain, they are measuring the movement, right? Now after measuring all these data, this data is sent to the central system for analysis, right? So now the engineers have this data, they will use this data to locate the damage and predict the future risk, right? Suppose this sensor reading, they have found that there is a vibration level is more, then the engineers finds that there is some defect at this point, and they will address the issue. Benefits, right? Improves safety and reliability, right? Reliability, trust. Now it trust is increased, right? Now enables preventive maintenance, right? It enables the preventive maintenance, means the maintenance before some big damage is going to happen. Reduces repair cost and downtime. As I said earlier, if we find the problem as early as possible and we repair it in that time, the reduced cost, the repair cost will be very less. Support smart city infrastructure and planning, right? These are the our structural health monitoring in the cities. Now smart surveillance, right? Surveillance, right? Whenever the moment we say surveillance, the CCTV comes into the mind, right? Whenever we say the surveillance, the CCTV comes into the mind, right? So now, here and nowadays we can see on the roads, even in the traffic, even in our campus, we can see the cameras installed everywhere, right? These are the part of surveillance, right? Surveillance means monitoring the public, right? So let us see what are those surveillance problems in the city. Ensuring safety and security in cities is challenging without real-time monitoring, right? We need real-time monitoring, then only we can ensure it. Manual surveillance is limited and hard to scale, right? Whenever we say manual, it means we need manpower. So we don't have that much manpower to do surveillance, right? And it is difficult. Every person, human have own limitations. They can't do surveillance. They can't keep where the criminal activity is going on. They can't check whether what is happening in the jatra. Right. So better, what is the solution? Use smart surveillance. Smart surveillance, what will they do use? They use interconnected cameras. They use internet connected cameras across infrastructure, transport and public spaces. Video feeds are stored and analyzed in the cloud to detect the events and patterns. Let us see how it works. Cameras are installed everywhere in the city wide and connected to the internet. Those cameras will collect the video data. They will send it to the cloud-based storage. Now, what happens? The analytical applications, right, can scan these footage to identify the specific events or threats. They will check whether this event, right, suppose there is a railway station, right, there which accommodates only 500 people, but already 550 people are inside the railway station, and the infrastructure of the railway station is not that good, so they can evacuate out the 50 people, right? That by that way they can avoid the stampede, right? Either by taking the preventive measure or after, right? They can avoid the these things, right? Or suppose, right, a building can a railway station example, that's enough, right? Even we can check like this also. In a bus have the capacity of 50 people, but there are 60 people. All those things, like we can do the surveillance, because nowadays we also have the cameras in the buses also. If you observe, there are some buses have, right, government buses, we can see cameras, right? Alerts and insights are shared with the security and city systems. Okay, the security team will be sitting in the control room. They will be observing, they will be taking this video data, and they will be checking whether there is a possible stampede, or there is any theft is, or any some people antisocial elements are creating the problem, right? Once they see in the televisions, right, in the control room, they immediately will come to that spot and they will take the necessary actions, right? So by all these things, what happens? It enhances the public safety and incident response, right? And again, it enables real-time monitoring and automated alerts, right? In the real time we'll get the information. It is not that stampede had happened, tomorrow we got the information. No, no, no. At such the scenarios where it is about to happen, immediately we can get the information, right? By automated alerts. Automated means without involvement of human beings, right? Maybe by message, by phone, or they will be, sometimes they will be watching the TVs in the control room, right? Supports event detection, yes, crowd control, and infrastructure protection, scalable for smart cities, right? Now emergency response. Okay, so this is the last application in the cities, emergency response problem. Let us see, right? See, emergency means what? An event which needs quick action, which needs quick action, which needs quick action, right? Or quick response, right? Otherwise there will be damage to the life and property, right? So let us discuss in details. Let us see the problem. Critical infrastructure like buildings, pipelines, and transport systems. Maybe it is a bus station, maybe it is a railway station, it is a railway, whole network of railway track can face sudden failures, right? Sometimes we get the news, right? The trains are not running, are delayed because the tracks are filled with water. There is a heavy rain and the tracks are filled in water, right? Such information we need as early as possible, right? Because it is a risk to the human beings, the life of human beings, right? Now without real-time monitoring, response delays can lead to major damage or safety risk. So what is the solution? Of course our IoT is going to provide the solution. They monitor the infrastructure using sensors, audio and video feeds, right? Now these feeds, the data is analyzed in near real time to detect emergencies and alerts. Okay, so let us see how it works. Sensors are installed across critical infrastructures, right? Right, gas, water, transport, power. Now, suppose what there is a breakage in the pipeline. See here also there is one pipeline. There is a breakage in pipeline. When there is a breakage in pipeline on the roadside, the road will be blocked, and also there is a wastage of water. So now I get the data immediately, right, which is sent to the cloud-based system for aggregation and analysis, right? We have multiple inputs, right, which help to detect the adverse effects. Alerts are sent to the emergency teams and systems for quick actions. Or some water pipeline is broken, the alerts are sent to the municipality people. They come and attend, repair the pipe immediately, so to avoid the loss of water as well as any other harmful damage, right? Maybe when the road blocks, it also may lead to accident, right? Benefits: faster emergency response, improves public safety and resilience, supports real-time decision making, right? Now it integrates with smart cities, right? So these are, right, these are the applications of IoT in cities, right? Whenever we include all these application in a city, that city is going to become a smart city, right? This is the concept of the how. Yes, there are many applications. We have seen only 6 applications, right? There will be plenty of applications, right, depending upon the problem that emerge, right, making it as a smart city, right? So in the next lecture we will be seeing the next application, that is the application of IoT in the environment. Okay, so thank you very much. Please keep on revising the subjects again and again.